how matter is made and where antimatter is. God tirelessly plays dice under laws which he has himself prescribed. Albert Einstein. I would add on to this. God plays all tables and at some he wins big. Let's summarize what we have learned about time dilation areas in our universe. They are abundant, vary in size, can vary in boost that provides a barrier level, and they can be stealth. Be stealth. And we have learned that slower time can switch off some processes and faster time can switch on some processes. And in the past, time was slow, and it speeds up since. Let's go back in time when it was so slow that almost no process could run, and there was no output from any processes, neither matter or antimatter, nor even light. There was space only and mist of time, picture below. Then at some moment vacuum fluctuations started. Actually, they were always there, but happening at lower probability. Particles and antiparticles randomly get produced and get annihilated. Large differences in time speed, time dilation, spawn matter. Vacuum is unstable, virtual particle-antiparticle pairs appear, but next moment they disappear, annihilate. But uneven flow of time in an area throws this balance off. Some pairs miss rendezvous, miss coming back together into vacuum. In the text below symbol stays for math power, 2 cubed equals 2 cubed equals 8. Even if probability of quantum fluctuation, particle-antiparticle production, is close to 0, p0 equals 1 zillion to the power of z illion, per cubic parsec per second. Even for such infinitesimal probability p0 equals 0.000001 that is still greater than 0. 1. Since spacetime is infinite both in space and in time, that means probability p equals 1 at any moment for all the space. Because p0 is multiplied by infinite number cubic parsecs in space. And p equals 1 at any cubic parsec if take enough time. Because p0 is multiplied by infinite number of seconds. 2. This process is very random, coming with irregularities of time in space, and such irregularities help in two ways. Positive boost at the time zone borders helps in pulling particle pair apart. Negative boost, check out what happens with velocity v3 in the first drawing. Helps to collect some stuff in the slower time gray areas. Does not matter how long or how intensive this process was and maybe still is, does not matter that most of real particle pairs annihilated into real photon pairs, sourcing cosmic microwave background, and does not matter that most matter and antimatter annihilated in white common area and in the most of gray areas, at the picture above. What matters is that in some, let's say zillion, gray bubbles out of all zillion to the power of z illion gray bubbles matter prevailed, and in some of them matter prevailed a lot, and in some other gray bubbles antimatter prevailed. Now God won because he played zillion to the power of z illion tables, and not the only one table like we tried before, in the chapter about black holes, where the only table was our universe. We find ourselves at one of such matter one tables, that is our universe. Just by looking a single level up, I have succeeded in explaining matter excess in our universe and where is the antimatter's asylum. That is enough for the task in hand, but let me take you further to see even bigger grand design, if we need to consider some chain of the processes having dependencies on the outputs of the prior processes. Actually, number of gray bubbles is not zillion to the power of z illion but it is infinite. That means if some process succeeded only at zillionth part of these gray areas, it is still infinite number of gray areas with success, infinity divided by zillion, meaning in every zillionth bubble. So, if there is a need to run next process that has a low but still positive probability of success 0.000001 and it requires output from some previous processes, still we have infinity of tables with output from the previous processes multiplied by probability 0.000001, that will still give infinite number of tables at which the process will succeed. So, it is doable. Such mechanism can produce almost anything improbable out of whatever improbable. Now space-time looks like multiverse and there is infinite number of matter universes, one of which is our, and infinite number of antimatter universes. What about CMB, cosmic microwave background? Most likely it comes from annihilation, and not from hydrogen formed in our universe, because our universe is finite, and light from hydrogen atoms formation left/crossed our universe long time ago. Can light travel between universes? We saw that light is mostly reflected back, and the tiny fraction of light that come out is dissipated over a half of space-time and it is redshifted. But answer is yes. Can object travel between universes? Most likely it cannot get out of its universe due to a negative boost, and even if it can, at a time zone border, it has to cross borders twice, his and our, it will be destroyed if boost is relativistic. In the first chapter, we saw that our universe had redshift z equals 11 in the past. Z equals 11 can give relativistic boost close to the speed of light, 2z plus z squared. 2 plus 2z plus z squared, c equals 145 c equals 0.986 c. Even for z equals 1 boost is 0.6 c. What is the size of our universe? Much more than 32 billion light years. Some zeros should be added at the end. Are there galaxies farther than 32 billion light years away from us in our universe? Yes. But we don't see them yet. Some of them already lightened up, but light have not reached us yet, and some of them have not lightened up yet. Remember, long time ago time was very slow, and processes in spacetime are switched on when time is fast enough. Are there dark stars and dark galaxies a few billion years from us, or even at closer neighborhood? Yes, and again of two types. They are just not heavy or not dense enough, do not have critical mass to lighten up. Or vice versa, they are too dense or dead, that we discussed in the chapter about nearly black holes. But because time speeds up, they will lighten up at some point of time in the future. Read more in free ebook Time Matters at play.google.com or at amazon.com. Amazon.com. Burning time in labs and in galaxies. Our sun burns hydrogen into helium, and sun can burn hydrogen in its core only where hydrogen is dense enough. Some stars burn helium into carbon, carbon into nitrogen, nitrogen into oxygen. And lots of photons and neutrinos are generated in such burning. In this chapter we'll talk about time burning into particles, matter, antimatter, photons. In the middle of this book, we described that long time ago, when time was very dense/slow, time was burning into matter, and antimatter, of which our universe was made eventually. Apparently, time should be very dense/slow, meaning spacetime has high energy, to burn into matter easily, otherwise we would have seen it burning everywhere. And it still burns in some areas. Let's recollect where slow time could be found. Everywhere, long time ago, at the Milky Way center now, because of strong gravitational time dilation. Inside energetic particles, because of strong relativistic time dilation. CMB, cosmic microwave background, isotropic 2 mm wavelength radiation, previously was speculated as coming from hydrogen atoms formation following the Big Bang, and the original wavelength was 1,000 times shorter than 2 mm. But since we debunked Big Bang, we can speculate now that it comes from the annihilation of matter and antimatter produced out of time. Wavelength of annihilation photons is billion times shorter than 2 mm, if it comes from electron-positron annihilation, and it is trillion times shorter than 2 mm, if it comes from proton-antiproton reaction. It includes decay of intermediate particles. Proton-antiproton annihilation is more complicated than just electron-positron annihilation into a pair of photons. That means redshift z for the CMB from annihilation is in billion to trillion range. Thus, time was billion to trillion times slower back then. So, particles produced at that time encapsulate time that is billion to trillion times more energetic/slower than time is now. Is it even possible for particles to encapsulate such an energetic/slow time? High-energy particles are observed in cosmic rays or made in accelerators by speeding up protons or electrons. Forbes.com lists the top energetic particles obtained/observed. Proton at CERN 299,792,455 meters per second, electron at CERN 299,792,457.9964 meters per second. In cosmic rays 299,792,457.999999999999918 meters per second. Let's analyze the winner and calculate what is the relativistic redshift z for such cosmic ray particle, from a known formula. Z plus 1 equals 1 plus v slash c 0 middle dot 5, 1 volt slash c 0 middle dot 5, equals 1 plus 1 0 middle dot 5, 1 to 299,792,457.999999999999918, 299,792,458 0 middle dot 5, equals 2 0 middle dot 5, 82 times 10 dash superscript 1 5, 3 times 10 8 0 middle dot 5 equals 341 times 10 squared cubed 0 middle dot 5 equals 85.5 times 10 9. Time in this moving particle is 85.5 billion times slower compared to when this particle was at rest, when time was encapsulated at the particle creation. If we knew what was time density at rest, then we can multiply by 85.5 billion to understand what is time density in that particle now. If assume that such ray was created 32 billion years ago, farthest real observed area, when rest time was 12 times slower compared to today's time. Remember farthest time zone with z equals 11 in the first chapter? Then the original rest time encapsulated in such particle is 12 times slower than we experience now. We need to multiply our current second by 12 to get the original rest time second of the particle, and then multiply it by 85.5 billion to get its second in the cosmic ray. 85.5 billion 12 equals billion to trillion. Thus, second in the cosmic ray is billion to trillion times longer than our second, meaning time in the cosmic ray is billion to trillion times slower than the time we live in. This real cosmic ray justifies particles' ability to carry such an energetic / slow time inside. Now, back to CMB, the hypothetical billion to trillion slower / denser time at the matter formation arrow looks plausible. Particles are able to carry such time. Let's talk about accelerated protons that are used for antiproton generation at CERN and Fermilab. n.wikipedia.org, antiprotons are created by impinging a proton beam from the proton synchrotron on a metal target, iridium core, which is an extremely hard and dense metal. At first it looks strange, why an accelerated proton hitting a static target proton produces antiproton instead of producing helium like Sun does. If you ask this question, you will get a quantitative answer. It is because protons in such accelerators and in Sun are very different in energies. But actually, difference is qualitative, and it is related to the time burning directly. Proton acceleration slows time inside the proton. People can slow particles' time by accelerating charged particle in strong magnetic field. Now, instead of thinking that we threw near light speed proton into the metallic static target, let's think in reverse. We smashed iridium core at the proton which has slow time inside. We changed this experiment perspective from proton is the bullet and iridium is the target, and the proton at near speed of light hits the target, to the reversed perspective where target and bullet change roles. Iridium is the bullet and proton is the target, and iridium at near speed of light hits proton that has very slow time inside it. Universe bombards nearly black holes, where time crawls slowly, by cosmic rays all the time. But our smart scientists found a reversed way in the lab. Target, iridium core, hits a bullet, slow time proton. Now we will show that antiproton was produced by burning time. That is what was happening. It is the main part of the chapter, and the mechanics of it will shed a light on what is going inside Milky Way. And we will understand the iridium choice. Let's consider general case when some object or some particle crosses time zones. Time zones. Let's consider two cases. I picked some small and big number pairs to ease the calculations. Object velocity v equals 0.2 c and red time zone redshift z equals 9. Object velocity v equals 0.9 c and red time zone redshift z equals 0.2. In either case, there is no problem for the top of the object moving through the white time zone. But we will see the resistance and impossibility for this object moving through the red zone. 1. For v equals 0.2 c it takes about 5 seconds of white zone time to go from A to B. In red zone, where time is z plus 1 equals 10 times slower, only 5/10 equals half a second passed for this move. But distance from A to B in the red zone is the same 299,792,458 meters, so our object in red zone moves at 299,792,458 meters, half a second equals 2c, twice the speed of light. 2. For v equals 0.9 c it takes about 0.9 equals 1.111 seconds of white zone time to reach B. In red zone time is z plus 1 equals 1.2 times slower, and 1.111, 1.2 equals 0.926 seconds past there. So, object velocity in red zone is 299,792,458 meters, 0.926 seconds greater than 299,792,458 meters per second, greater than the speed of light. This speed limit violation can be resolved in two ways only. Either object is destroyed when red area is touched, or time speeds up along the object's trajectory, above the thick blue line. There is nothing interesting to learn from the destruction scenario, except that it explains iridium choice. It is very tough material to destroy, and that iridium rod plays the role of an object hitting slow time inside the accelerated proton. Let's talk about resolving the situation by time speeding up at the object path. 1. For v equals 0.2 c let's figure out what redshift x will not violate the light speed limit. With 5 seconds passed at the white zone, 5/x plus 1 second passes at the red zone, thus, 299,792,458, 5/x plus 1, should not be greater than c equals 299,792,458 meters per second. Therefore, 299,792,458, 5/x plus 1, less than equals 299,792,458 meters per second. X plus 1 less than equals 5. X less than equals 4. Changing redshift from 9 to 4 in the pink area, see the image below, solves the problem. That means time at the pink area loses energy to the particles radiated out. That resembles Cherenkov effect, see below. 2. For the second pair of V and Z, the outcome/solution is the same, time burning in the pink area, the same image above. Time from A to B in the white area takes 1.111 seconds. With a new redshift x in the pink area, the same path takes 1.111/x plus 1 second of the pink area time. Thus, to travel a distance of 299,792,458 meters we need at least 1 second, so x plus 1 less than equals 1.111 solves the problem. Redshift change from 0.2 to 0.111 abides the speed limitation. In a way, it reminds of Cherenkov's effect for a charged particle traveling in water with a speed faster than speed of light inside the water, which is around 26 million meters per second c. Blue light is radiated from this particle until the particle slows down to the speed of light in the water or even below. In our case, such Cherenkov-like radiation consists of particles, antiparticles and high-energy photons. And time at the path is partially burnt from red to pink, to a redshift value that allows such movement. We have understood why antiproton is generated from an accelerated proton in the iridium target, through time burning. Now we can apply this knowledge to what is going on inside Milky Way and in other spiral galaxies. In the second chapter, we discuss time in spiral arms running faster than in the gray areas between the arms. Based on Vera Rubin's data, the gray areas are redshifted at about z0.001, exact value varies by galaxies, in comparison to the arms. In the second chapter we use Doppler effect analogy to figure out velocity boosted on stars leaving an arm. But now, we can redo it simpler using the energy invariance principle. When a star moves from an arm to a gray area, from faster time to slower time, the energy of the system goes down. See the second part of Energy Measures Time chapter. So the speed of the star should go up. See the first part of Energy Measures Time chapter, to compensate the energy loss. Now, why arms exist at all? Those arms are streams of burnt out time. Second is shorter, energy is less there, from inside the galaxy center, bar or disk. Burnout rate is moderate, Z 0.001 means 0.1% rate. In the center of the galaxy, gravitational time dilation is very strong, and on top of that dilation, there are massive stars in the galaxy's center, nearly black holes, so dilation around them is even stronger. Thus, particles and objects hitting such areas burn time on their passage exactly as it was described for the pink area above. Particles, antiparticles and a lot of annihilation photons are produced there. But because galaxy center has strong time dilation, produced radiation is redshifted to us, and energies/frequencies observed seem lower. Charged antiparticles that avoided collision/annihilation at the galaxy center are thrown out from the galactic plane into the galactic bulge by the strong magnetic field of the galaxy, and they annihilate in the bulge and give out radiation. All that explains energetic and random radiation in the galaxy center, and where spiral arms of burned out time come from. They are the exhausts/chimneys of the galaxy. And if you remember how matter is made and where antimatter is chapter about early days of space-time, when our universe was getting matter, same reasoning could be applied there. When particles from a faster time area enter slower time areas, which I drew as gray bubbles, see the second picture in that chapter, that can cause particles, antiparticles, photons, bursts and time burning, if the particle violates local speed limit.